Hello everyone, my name is Alexander Ilic. I'm a senior BIM manager at BEXEL Consulting and member of buildingSMART International Professional Certification Program Development Group. Today I will present you knowledge-driven automated 3D, 4D and 5D workflows in openBIM environment. At the beginning, before we start with the topic, just a brief introduction about BEXEL. BEXEL is a software development and BIM consultants company with experience on numerous projects around the globe. We are multinational members of buildingSMART International and we are devoted to integrated BIM project management, BIM education and BIM implementation. Last year we won Innovation Award at buildingSMART annual competition and we are very proud to be recognized as leaders in innovation in field of BIM. Our software solutions and consulting services are used on numerous projects by big, well-known companies around the world, and we are proud to say that we gain trust from so many renowned clients. Our software platform is present at 55 countries around the globe, and our user interface is localized in 10 languages with new localizations in development. BEXEL Manager software solution is currently used for managing projects of total value exceeding 90 billion US dollars. So, to move to today's topic. And today's topic is automation, or namely automation in BIM. When we think about automation or the problems of automating repetitive tasks, the most of us visualize the problem like this. We just see a bunch of people working some manual, labor-intensive work that could or should be automated. And if we envision solution, we mostly see it in this way. We see it as a bunch of intelligent robots doing some labor-intensive or repetitive or boring work for the humans. But the reality says that in digital industries as well, a lot of work is still repetitive work that could be easily automated. Somehow intuitively we imagine that if we have digital workflows, our workflows are efficient and automated, which is just not true. Some studies have shown that office workers spend more than 3 hours a day on easily automatable tasks, so it's a huge amount of time that is lost. And if we talk about construction industry and BIM itself, it's probably the same situation, because yes, BIM allowed us to integrate huge amount of information, to have ability to easily exchange this information from a single source of truth, to have a very streamlined communication between stakeholders. But what we still have to do is we still have to do a lot of manual work, a lot of repetitive tasks to maintain this database, to import information and to update the information. And as a result of this, a huge amount of this information model data layer is project specific information. It is something that you are using on the project and that you are developing and creating and updating through the through the project execution, but you don't have ability to reuse it on the future projects, or just to simplify it, you have to start from the blank sheet of paper on every new project. So if we talk about BEXEL Manager and workflows in BEXEL Manager, this is a scheme that is probably familiar to most of our attendees today, is that BEXEL Manager allows additional module that is dedicated to knowledge-based management. What this means? This means that it allows you to actually create your knowledge base and to reuse it in your workflows in the next project. So today we're going to focus on this module or these functionalities of BEXEL Manager and this approach to BIM workflows in general. So what this means? This means that you are not gonna create, or you're not gonna recreate your analysis from scratch on every new project, but you're gonna set your procedures, you're gonna set your set of rules, and you're gonna easily reuse it on the following projects, and you're gonna just simply increase productivity by doing this. This is how it is done in BEXEL Manager. Today we're gonna just go through some basic model analysis and basics in different stages of the project, and we're gonna demonstrate the level of automation and the level of or the possibilities to reuse the knowledge from the knowledge base. So the first analysis that we're gonna demonstrate today is a simple model analysis. This means the organization and sorting of the model elements according to certain rules. It's actually a preparation of the model for the future stages of the project, preparation of the model to be easier to manipulate, easier to navigate through. And this is done in BEXEL Manager basically in three basic workflows, or with the three basic functionalities, with the selection sets, custom breakdown structure, and quantity takeoff functionalities, which also allow visualization of the model data. And today we're going to demonstrate how these processes, how these workflows could be actually streamlined using using functionalities that allow you to import predefined set of rules, predefined templates for this analysis, and how this can help you to transfer your knowledge from project to project. For selection set import, user is now able to actually predefine selection sets, smart selection sets based on the rules, and to import them on the project or to transfer them to the future project. So we're going to just see one simple example. We're going to import one of the selection set templates already prepared. So let's say the first one, let's just see how it looks like. It's a very simple example in which we want to identify all the doors on the project, and we want to separate them by the swing direction, if it's left or right door swing direction. So we're gonna open, we have imported the selection sets, and we can first easily isolate all the doors in the project, and then we can easily select the ones that have swing direction left or right. So this is on one really simple example. And we're gonna demonstrate one more example where we're gonna import selection set template where MEP elements are rated by flow rate. We're gonna open it, and again we can very easily select all the elements that contain this property and identify different groups based on the value of the property. So one of the very important possibilities of BEXEL Manager is that you have ability to prepare templates for your custom breakdown, including color coding rules, which will apply on every new project. So let's say that we want to visualize this set of properties. So we want to isolate these elements, and we want to color code these elements based on the values of the properties. What we can do, we can just select them. We can go to custom breakdowns and create new custom breakdowns from selected elements, and we can name it flow rates, use selected elements. And instead of creating custom breakdowns, we're gonna import predefined template. So we're gonna open predefined CBS template that's called HVAC flow rate, and we're gonna organize elements in this way. So if we go to 3D color coded view, we're gonna see that based on the values of the property, these elements are actually color coded. So to demonstrate the advantages of this approach, we're gonna try to recreate this same custom breakdown using the same selection set template on a different model. So we're gonna open a different model of a high-rise building, in which we're gonna first import selection sets. So we're gonna import the same selection sets as the last time. Again, as in a previous example, we're gonna select the elements of the model. We can isolate these elements, go to custom breakdown structure, create from selected elements, and instead of creating CBS, we're gonna name it flow rate. Instead of creating CBS from scratch, we're gonna again try to import template. So we're gonna import the same template. We're gonna go to the color coded view, and we're gonna see model elements colored in the same color scheme as it was defined in the previous model. So all these templates are based only on the properties, rules and values, and could be reused on numerous projects. Another very important feature is quantity takeoff, which basically contains all the functionalities of custom breakdown structure, but also allows user to quantify the quantities of certain model elements. So for all model elements or selected model elements. Here we're gonna just demonstrate one quick example. So we're gonna use all model elements in this way. We're gonna call it demo QTO, and we're gonna break down elements, let's say by building level, by category, and then by family. And we're gonna add the count, we're gonna add quantity area, let's say, we're gonna add quantity volume, and we're gonna add quantity length. So we can color code it, let's say by category. Click OK, and we have our custom breakdown structure basically with the quantities of the elements as well. If we want to visualize this analysis, we can just go to color coded view, and instead of custom breakdowns, visualize it by quantity takeoff. We can also select elements, isolate them, identify it easily, and so on. We also have ability to export 3D to export reports to Excel, and we have ability to exchange information with other stakeholders. What is also important for this analysis is that we, as with the CBS and with selection set, we have ability to create templates, and we have ability to exchange the templates and to use prepared templates for our analysis. So we're gonna now create a quantity takeoff analysis based on a uniform code. So we're gonna again use all the elements of the model. We're gonna use selection, and instead of creating the quantity takeoff manually, we're gonna import QTO template, which is made for uniformat. And here it is. We have the elements organized by uniformat code, and we're gonna see that we're able to get all the project elements organized by a uniformat coding. We can go to the 3D color coded view and visualize elements by uniformat organization. After model elements are properly sorted into groups that allow user to easily navigate and control the model, the next important step is data validation, or checking if the data in the model are corresponding to the set parameters or set rules in the BIM execution plan. This process could be executed manually, so user can go through the sets of data and check if these data comply with the rules specified in the early project phases. But this will also be extremely labor intensive task with a lot of repetitive work. So our approach is different. Our approach is that user is able to define the set of rules, the set of properties that should be populated, and the way they should be populated and formatted, and that computer engine through an open API add-in is able to check the validity of this information. So we're gonna go back to our BIM model that we were using for previous demonstrations. We're gonna go back to 3D view and we're gonna start data check on this model. So we're gonna go to add-ins and we're gonna initiate property checker. We're gonna now open configuration file or template file in which all the properties and all the rules for properties populating in the project are defined. This means that in this checklist or in this template we have defined all the phases of the project. We have defined for every category of the element the set of properties that should be defined, the property set group in which these properties should be placed, the value type of the property, the phase in which this property should be populated in the model, as well as key, which is actually for certain properties. We're gonna also add additional check which will check if the properties have the proper value from the pick list, which defines which properties from this list are valid for certain property. So we're gonna close this Excel file. We're gonna open configuration document. We're gonna choose the phase for which we want to check the properties, because depending on the phase of the project, the amount of the properties are different, because in the early stages of the project you need less detailed data layer than in the later stages of the project. You can also choose if you're gonna use all the elements of the project or selected elements only, and we're gonna just click run to execute the analysis. Data validation process is now complete, and the results are generated in the form of selection sets which contain the failed property explanation, and the results of the analysis could be exchanged with other stakeholders simply through BCF manager by simply drag and dropping created selection sets and sending it to other stakeholders. The results of the analysis could be also exported to Power BI dashboard by simple clicking export to Power BI. So Power BI export is now complete, and we're gonna open exported Power BI file. And there it is, exported detailed Power BI dashboard about data validation process that we have just executed on the sample project, with a detailed list of all the issues identified by data validation engine. After data validation is completed, the next step for managing your project is data enrichment. That means that yes, certain properties that were not properly defined could be sent back to other stakeholders, designers, to change it and to correct it in the authoring tool, but certain properties could and should be added by project managers directly in management tool. This process in BEXEL Manager is actually automated to a high degree with the introduction of a specific Open API add-in, which allows user to define configuration document or template for data enrichment, or to simplify it, to define which groups of elements with which set of properties should be enriched with additional property based on the existing properties. We're going to just now briefly demonstrate this process on the sample project. So we're going back to our demo project, and for this specific functionality we're gonna again try to import selection sets. This time it's gonna be a set of selection sets which are grouping model elements by uniformat codes. So we're gonna import selection sets. Selection sets are imported, and then we're gonna be able easily to identify which elements in the model contain uniformat classification codes. If we hide them, we're gonna see that MEP model elements doesn't have corresponding property for uniformat. So we're gonna use data enrichment add-in to populate automatically the corresponding codes to the elements. How we're gonna do it? It's pretty simple. We're gonna just initialize the import properties from BEXEL add-in, and we're gonna open data enrichment configuration file, which actually contains defined rules for model enrichment. That means that model elements with combination of category, family, and system names for certain elements and certain families should get corresponding uniformat code. So if we just click open, as a result we're gonna get another set of selection sets which will allow us to check which elements actually got new properties from Excel file. And we can see that these were all within the services group of works. And if we go back to our selection sets that were imported at the beginning, we're gonna see that MEP model elements now got their properties for uniformat cost classification as well. And if we go and check one of these elements in the property set, we're gonna see that it now has uniformat code properly defined. After we have completed data management of our BIM project, the next logical step is validation of geometrical attributes of your model or clash detection. This process again is time-consuming process which includes a lot of updates, a lot of configuration of the clash jobs, a lot of work on organizing the groups of models that should be checked against each other and so on. And if we look at the process more in detail, again it's actually set on the certain principles, on the certain set of rules that could be and should be followed on every project. So in BEXEL Manager we allowed user to actually predefine selection sets that will organize model elements in the groups to be ready for clash job definition, as well as definition of the clash matrix. And today we're gonna demonstrate how this process works, how actually user is able to import selection sets, predefined smart selection sets that will organize the model in the groups that will be confronted in clash detection analysis, and import clash matrix which will define actually the list of the clash jobs to be executed on the model, and the user basically only has to update predefined clash analysis and to get immediately results for complete project for all clash jobs that are defined in configuration file. So for the clash detection analysis, we're going back to our basic sample project. We're going to clash detection module, and here we see that we don't have any active clash jobs. To initiate clash analysis, we first need clash selection sets. That means a set of selection sets which will serve as the basis for our clash analysis. So first we're going to import selection sets, again using add-in for the selection set import. We're going to just quickly inspect the source file. And here we can see the groups of work packages and the groups of elements that will be confronted against each other in the clash detection analysis. We can also see the queries that are based on the properties of the model elements that will actually group corresponding elements to the groups that we need for clash detection. So we're gonna import selection sets. We're gonna check our selection set, so everything seems to work properly. And now, instead of going and creating one clash job at a time using our selection sets that we have imported, in BEXEL Manager, user has ability to actually import template from Excel. So the user can just click import from Excel, and user can define all the selection sets on the project. It can be predefined, just referring to the selection sets that were also predefined in the configuration file or the template that was previously imported. So here we can see the name of the clash analysis that we're gonna execute. We see the priority of the clash analysis from 1 to 3. Here we see left and right side of the clash detection analysis that are referring to the selection sets that we have just imported. And here we can see the clash type details, the tolerance, and if we're gonna exclude or include clashes within the group. So all these parameters are predefined in the form of configuration file or template and quickly imported into BEXEL Manager. So in this way, we're gonna be able to practically execute 37 clash analysis at once. So we're gonna save this file and we're gonna go and open this template. So now we have imported all the clash jobs. All we need to do is just go and update all clash analysis at once. So the clash detection analysis is completed. We can go and check some of the clash detection analysis, check some of the clashes. We can see where the clash happened. And what else we can do, we can actually exchange these clashes again using BCF exchange by simple drag and drop into BCF Manager. So every single clash or multiple clashes could be simply drag and drop and send back to the other stakeholders to check for the clashes. After clash analysis was executed, as I said, 37 clash analysis at once. So all of these clash analysis were basically executed simultaneously based on the predefined configuration file. User is also able to export it, to export all elements, or to export just a partial clash report in PDF or Excel file. Now we can turn off clash view mode and go back to 3D view. So the main advantage of this process is that it saves a lot of time, and it saves a lot of time on every new project, on every new update, and that it is scalable. And we're gonna just quickly demonstrate it by going to this big sample model, where we're gonna, again, using the same templates and the same configuration files for clash analysis, recreate clashes. So first we're gonna import clash selection sets. They're based on the same rules as for the small model. We have imported selection sets. So here are the clash selection sets, again in the same way organized as with the model of much smaller scale. And based on these imported configuration files, we're gonna go to the clash detection and we're gonna import the same clash matrix that we were importing in the small scale model. The clashes are here. We're gonna again just simultaneously update all clash analysis. So clash detection analysis completed. And if we go to some of the clash analysis, we can see the results of our predefined clash analysis. So no matter the scale of the project, if you prepare your knowledge base, if you define your configuration files in a proper way, you can save incredible amount of time in checking the quality of your BIM models. Another important feature when it comes to clash detection is actually a functionality for automated grouping of clashes. So in this case we're gonna open a hard clash analysis and we're gonna try to select all the clashes and to group them by the left member of the clash group. And now we're gonna see that the clashes are grouped based on the left member of the clash analysis, and it's much easier to manipulate with the model, and it's much easier to visualize the clash results using this useful functionality. And for the end, we're gonna export report to Power BI. So we're gonna uncheck other analysis and check only clash jobs for export. We're gonna save it on a computer, and after export is complete, we're gonna open Power BI analysis, go to clash detection dashboard, and here we have complete data about all clashes on the project. We have detailed list of all the clashes, or we have ability to filter it by clash job. We have spatial distribution of the clashes on the project, and we have more or less detailed analytics about number of clashes per type of clash and all relevant information regarding clashes. So after all 3D analysis are completed on the project, the next step is a cost management or integration of the cost information into BIM model. And when it comes to BEXEL Manager, there are two main workflows. The user has ability to create BIM-based cost classification. That means that user is able to rely on previously generated quantity takeoff or CBS analysis that we were performing in the previous examples, and then by using creation wizard generate cost classification, which then could be fine-tuned, auto-assigned to the model elements, and created into full cost classification with integrated unit costs and quantity formula information. Another approach is that user is able to import cost classification in the form of template or configuration document. This configuration document is completely free in terms of which type of classification it is. So there is no limitation in the type of classification. So in this case, we have just mentioned some of the well-known standard cost classifications around the globe, but basically any cost classification could be imported in the form of Excel spreadsheet or through an add-in in BEXEL Manager. And this cost classification then could be auto-assigned to model elements and fine-tuned for some additional information and integrated with the BIM model, so that the model becomes the 5D BIM model with integrated cost data. On the same project, you can have multiple cost classifications, you can compare them, You can export results to Power BI. You can export back to any format using BEXEL Manager add-ins like BC3 or GAIB format, and you can actually that's something that we're going to talk about on the next example. You can base your construction methodology on your predefined cost classifications. So again, here as in the previous example, the focus is on configuration document or template. That means that once you prepare your cost classification, you're able to export it back to Excel or exchange it with another project through a BCF file, and you can reuse this classification on all your future projects. So you don't have to start from scratch on every new project. You can have your predefined procedure, you can have your predefined cost classification with all relevant information set and saved in the knowledge base and reused on every new project. So first, we want to try to create a cost classification that is based on the available information in the model. What this means? This means that we're going to try to create cost classification that doesn't require specific coding system to be implemented to the model elements. So how we're going to do it? We're going to try to organize cost structure by groups of works or work packages, then by the category of the element, and on the lowest level on the family name of the element. How we're going to do it? First, we have to organize works into work packages or groups of works. So we're going to just import these selection sets. Here we have them. So first of all, we're going to select these groups of works, use it from selected elements. We're going to name it QTO based work breakdown structure. Use selected. So first we're going to organize our QTO by these 4 selection sets, so to get these 4 groups of works. Then we're going to use category as the next level of organization, and at the lowest level we're going to use family. For the quantities, we can add count as the most basic calculation rule. We can add, let's say, area. We can add length. And we can add volume, because those are basic calculation rules. We can also decide to color code it on the category and click OK. So right now we have our work breakdown structure QTO organized in this way. So first we have groups of works, then we have categories, and on the lowest level we have family names. So this QTO will serve as the basis for our cost classification that will be created using Smart Cost Classification Engine. So we're going to go to Cost Editor and we're going to create new blank classification. It's going to be QTO based cost. Before we start with Creation Wizard, we can also define the coding system for our future cost classification. So in this case, I'm gonna use this level. So on the highest level, I'm gonna use uppercase letters, 1 symbol length, and I'm gonna use dash as a separator, let's say. On the next level, I'm gonna use numbers, 2 digits, and again dash separator. And I'm gonna repeat this logic on the lower levels of this cost classification. So now we have everything ready for the creation of our cost classification. So we're gonna just go right click, Creation Wizard, and we're gonna create it from quantity takeoff. So we're gonna choose which quantity takeoff we want to use as the basis. We're going to use the coding system to be schema. It could be codes that are populated in the model in case you are basing your cost classification on certain coding system. You can also specify the unit cost in case you have that information added as a property in your model elements. In our case, we don't have it. For the basic creation of the cost classification structure, the best is just to use count, because all the elements apply to this calculation rule. So we're going to just click OK. And here we have our cost classification created. So if we collapse it, we have 4 main groups of works. And then on the next level, we have all the elements organized by category, and on the lowest level by family. So right now, what we can do to further improve or fine-tune our cost classification is that we can just simply edit cost items. We can do it, on the level of specific cost item, or we can select group of cost items at once, and we can edit properties of this cost item. So we can define resources if we want. We can define quantity formula. So in this case, let's say we want to add volume for calculating the quantity of this cost item. So we're going to use volume, let's say, and we can decide the unit price. We can just specify the unit price as a single value, or we can just break it down by material supplement, labor supplement, equipment supplement, or we can define detailed resources. It depends on us. So in this case, I'm going to just specify, I don't know, 100 US, let's say. I'm going to specify the quantity type and quantity unit. And if I click OK, for all these selected cost items, I have enriched it with additional information regarding cost and regarding quantity formula. Of course, you can even further enrich this cost classification. So let's say you want for the beams to create additional level of classification. So you want to segregate beams by, I don't know, let's say formwork and concrete and reinforcement, let's say. So you can add these additional levels of organization, and you can simply just copy these cost items to these additional levels. So you can just copy and paste. You're going to see that the coding is automatically changed. You can additionally use creation wizard, so you can enrich it further if you want to add certain categories that were not part of your initial BOQ. But since we don't have time for this presentation, we're gonna also try to import already prepared cost classification to demonstrate further steps. So we're gonna first again create empty cost classification, and then we're gonna simply import. So we're going to just open the file to see the structure of the configuration document. So basically we have just the basic information in the same way as in cost classification in BEXEL Manager. This format is completely open, and it could be used for integration of any customized or standardized cost classification. So we're going to just proceed, import it. If we expand, we're going to see that it has the same logic and the same structure as the QTO based cost classification that we were creating in the previous example. So the next step is just to auto assign to new cost version. That means that we're going to now connect cost items with the model elements, and in this way we're going to get the project budget basically. So we can easily select and isolate elements that are linked to certain cost item, or we can select the element and filter by element selection to see what is the price and what are the cost items related to these selected elements. Besides this, we have also ability to add variable costs. We can define markup, overhead, material markups, and taxes, all different costs as a percentage of construction costs, and we can apply it to every cost item separately, or to the groups of works, or to the whole cost classification and cost budget. And we can also, with the column chooser, we can customize which cost information we want to have displayed in this budget list. Besides this, one new very important feature is that now we are able from BEXEL Manager 21 to alter the structure of the budget. So basically what we can do, we can ungroup assignments, and we can recreate custom structure of the cost classification or of the budget by simply using Creation Wizard. So we can first recreate classification level that we had. And we're gonna also add, in this case, building levels as the additional level of project budget segregation. So if we click, we're gonna get all costs organized not only by defined cost classification, but also by building levels or building stories. So all the quantities, all the prices, all cost items are now broken down by every floor of this building, and this gives us opportunity to select it and to navigate through the model in this way. Of course, this feature allows you to organize the budget structure in any way and any hierarchy that you as a user want. And after we have integrated cost information into BIM model, we can proceed to the next stage, and that is scheduling. In this approach, scheduling is done after cost classification, because with the intelligent scheduling engine, user is able to define so-called methodology based on the cost classification, and the schedule is created automatically. What this means? It means that you can define the logic of work execution or the sequence of work execution by simply defining relationships between different groups of works, and these groups of works are related directly to cost classification. This also means that if you as user are using a certain cost classification, that is standardized cost classification for your market or standardized cost classification for your company, you can, for every new project, not only reuse the same classification, but reuse the same methodology and the same configuration files for the schedule creation as well. Today we're going to demonstrate this process as well, and we're going to show how this configuration files, or namely methodologies and zones for schedule creation, could be transferred between projects and could be used as a knowledge base for all future projects. So for this demonstration, we're going back to our sample project. We're going to show all elements, and we're going to base our methodology on the existing cost classification that we were just importing and assigning to model elements. So we're going to schedule methodology editor, and we're going to create new methodology, and we're going to create methodology only for the structural works of this project, because we don't have time to demonstrate the whole process, but we're going to see how the whole methodology for all works actually looks like at the end. So basically what we're going to do, we're going to just create new items. We're going to select our cost classification, and we're going to select groups of works from structural works, and then we're going to more or less intuitively just create methodology or the work sequence logic for these structural works in the office building. So we're going to start naturally with site preparation. Then we're gonna continue with the structural foundations. After that, we're gonna create finish start relation with the beams, or namely the foundation beams in this case. After beams, we're gonna have slabs. After slabs, we're gonna execute roofs, structural columns, and structural walls in the same time. So if we leave the methodology like this, the engine will first create all structural foundations, which is okay, and then start with the foundation beams, but then it's gonna start to create all the beams on the project, on all the floors. And since that is not a logical working sequence, we need to do one more thing. We need to select all the relations and to check copy to children. What this means? This means that this relation between, let's say, slabs and structural columns will be translated to the lower level of project organization. That means that when structural slabs on one floor are created, then the finish start relationship will be for the structural columns on the next floor, and not to wait until all the slabs are completed on the project and then start creating the columns, which would be completely unnatural. Okay, we're going to save this methodology, and again you have ability to transfer this methodology, to reuse it on the future projects as well. And now we're going to create the zones. What this means? Well, we have created the logic or the work sequence for structural works on this project, but we haven't created spatial structure for this model. That means that we have to create also the logic of works execution in terms of space. What this means? Well, for instance, we have to define building stories or building levels. So in this case, I'm gonna just create a new one, demo levels, and we're gonna just simply use building stories. We're gonna select them, and we're gonna click create relations, which means that he's gonna automatically create relations finish start between these floors. So it starts from the sub level to entry level floor, the second floor, third floor, and so on. So we're gonna save this zone as well, and on the lowest level we're gonna create phases. So for the phases zone definition, we're gonna use selection sets in which we were organizing project by phases, by separate phases. So we're gonna find selection sets, we're gonna select these three phases, and we're gonna again create relations. We can save. After we have completed this, we can just go and create creation template, which will actually combine these two zones and one methodology, and be a basis or a template for generating construction schedule. So we're going to go into construction template and create a new demo structural. We're going to use first methodology, the one that we were just creating, and then after that we're going to add zones. So first we're going to add levels, and then we're going to add phases, and now our creation template is ready for implementation. Now we're going to simply to schedule editor, creating an empty demo schedule. We're choosing the latest cost version upon which our methodology was based, and we're getting empty schedule, so we can just simply proceed to creation wizard, pretty similar as with the cost classification and all the previous automated workflows. We're going to just load the template that we were just preparing, click OK, and there it is. We have complete schedule created for the structural works of this project. and we can go right away to schedule animation and to check validity of our schedule. So I'm going to just change the duration of animation, and I'm going to change it to the hourly animation to be more detailed, and we're going to see how the works are executed with the sequence that we have just defined. And it seems that it works properly. So this is just a basic workflow. This is just for the part of the project, but you can see that the whole process is easily manageable, extremely automated, and the best thing of all is that you can reuse all of these methodologies, transfer it to a different project, and create schedule in minutes. And for the end, we're gonna just demonstrate how we can reuse methodologies created in one project on a different project. So we're going to just export methodologies. We're going to use one that we were creating as well as two additional. We're going to the different project. So it's a large scale model with multiple buildings. So we're going to import. We're going to check if it was properly imported. We have all the methodologies that we have selected, including the one that we were creating. But this time we're going to use this more complex methodology that covers all the works on the model. So we're going to just recreate new creation template. We're going to use methodology from the project that was imported. And we're going to use zones from this project. This means that we're going to transfer it by buildings, by levels, and at the lowest level by phases. We're going to use building zones as well, since it's a more complex project with multiple buildings. So we're going to just create new schedule. We're going to pop out window for better visibility, and we're going to create the schedule, loading the template that was created based on the configuration files or templates methodology that we transferred from the small office building project. Schedule is created, and we can see the scale of the schedule. It's multiple times bigger than the one that we were creating with the same methodologies on a small scale project. We can check the line of balance schedule. Again, it's of a much larger scale. And just to notify that this is not optimized schedule, this is just a basic schedule structure. With the further fine-tuning, it could be completed to be fully optimized in line of balance and resource-wise. So we're going to just check the animation. We're going to schedule viewer, and we're going to hit play. So it seems like construction sequence is pretty much the same as with a smaller building. Of course, in the final version of this schedule, we would probably need to a little bit customize the sequence, probably to make a facade to appear later, and some additional small things. But in general, what we achieved with this transfer is that we were able to basically scale up work that we were doing on a smaller project to a completely different project that only follows the same cost structure and the same technology of execution. And that would be it for today's presentation. I just want to thank you for your attention, and I want to thank organizers for this great opportunity to present our workflows and to present our approach to openBIM.